Hi guys, Pete here, N6QW, and this is the Simpleceiver Superhetrodyne version, one step up from the DCR. And this morning I wanted to just share with you some information about this particular configuration. Essentially we have an RF amplifier here, an SBL1 double balance mixer, which is converting the signals down to the IF stage, or I should say up. We're coming in at 7 megahertz and the IF is at 12.096. We have two J310s operating as a dual gate MOSFET on the first IF amplifier, an exact duplicate pair following the crystal filter, acting as a second IF amplifier. That goes into a product detector, which is another pair of J310s configured as a dual gate MOSFET. We have an audio amplifier stage here with a pair of NE5534 and an LM380, the 14-pin version. And we have a bandpass filter here. I'm moving the camera around a little bit. Bandpass filter. And again, the RF amplifier is J310s, and we have a Arduino Nano driving the SI5351. The BFO is 12.96 megahertz. So that's a configuration, and I'm trying to make a few improvements here. I added a little audio filtering so we can open up the gain and cut out some of the hiss, and that sounds a little bit better. We're operating at 7.032 megahertz. And I wanted to show you some functionality that's built into these boards. Essentially, the RF amplifier and IF amplifier stages have gain control pots in them. And the purpose of the gain control pots is we could add either a manual gain or an AGC circuit if we wanted to do that. And that may become a little more significant on when you make this a single sideband transceiver. Might want to have AGC. Now you have to do some clever work here, because we're ultimately going to use a lot of these boards here in the receive mode are going to be used in the transmit mode. So what we need to do is think a little bit about what may work as an automatic gain control on receive may not be the same desirable characteristics where you have automatic level control ALC on transmit. So we need to think a little bit about that, but I just wanted to show you how the gain was adjustable. I'm going to go here to the RF amplifier stage. And you can hear the gain change as I change the little 10K pot. Okay, that's minimum gain on all three stages. So that's quite a range of gain control. That's minimum gain. Now I'm going to increase. You can hear the background noise go up a little bit as well. So maybe you don't want to operate the RF stage wide open, but just enough gain to give a little boost to the signal. This was fun. 7 threes. I see him. This is at 9:14 in the morning. Tuning rate is 100 hertz. 110 hertz. Nice slow tuning rate. problem here with the mount. Okay. $10 Hz. I've retuned the bandpass filter so it favors the CW band. Here's without the audio. I've added a 10 nanofarad across one of the capacitors on the NE5534, and it sure cleared up some of that background noise, background hiss. So the 470 picofarad that's in the NE5534, just parallel that with a 10 nanofarad, and that'll kind of clear up some of the hiss generated by the chip itself. Okay, let's move this up to 1 kilohertz. Okay, as I said, I retuned the bandpass filter. This is Pete, N6QW.
It's required a lot of watering here at the facility. We last
7235.
$185 a month just to keep the grass and the shrubbery green.
Here the IF stage gain change. Anyway, this is Pete, N6QW, and this is the Simpleceiver Superhetrodyne version. I did clean up the noise generated by the audio amplifier.
Yeah, Roger. You know the old story, if I knew then what I know now, I would have taken this big backyard and zero-scaped it. When I bought this place,
I'll take another video when the band is more active later on in the afternoon, but I just wanted to clear up the background noise.
features and a lot of native plants that are used.
Just to give you a feel, that's without the 0.01 in there. There you go.
And Papillon. And boy, they spend an awful lot of time out there keying. They got a gorgeous backyard. But
N6QW here, 7 threes.